let us get started again. So we had a quite interesting morning with a bunch of speakers on some different but adjacent topics on brain-computer interfacing and such. And this is it's all part of the convergence of technologies toward a singularity. There's a lot more that wasn't covered this morning in that vein in terms of nanotechnology, quantum computing, and a whole bunch of other fascinating tech areas, all of which are advancing exponentially and leading toward quite dramatic potentials in the next few years. But now, in this session, we're going to verge back towards some of the things I talked about in my keynote this morning in the plenary session regarding decentralized AI networks and building decentralized AI toward artificial general intelligence, artificial superintelligence, and so forth. And for those who are part of the SingularityNET team, it's a little repetitious of what I talked about yesterday, but it's hard to avoid. It's the same SingularityNET project, right? And I want to dig a little bit deeper into what I alluded to in my keynote this morning. So what I talked about this morning was our quest to move toward artificial intelligence itself, perhaps move toward artificial superintelligence, and the ASI Alliance is pulling together SingularityNET, Fetch, Ocean, QDOS, pooling our software and communities together to make a sort of decentralized infrastructure for AI. Now, there's a bunch of you could get AGI to pop out of this decentralized infrastructure for AI, right? And I mean, one way, which is conceptually appealing, is a bunch of people just put different AIs in this network, and then AGI pops out of their coordinated interactions in a self-organizing way. And I think that could eventually happen. I don't think that's how it's going to happen first, because I think these sort of evolutionary processes are much slower than engineering processes, right? And what Trent is pushing toward with Predictor is more of a global brain type approach of like, how do you turn internet or a subset of the internet, which is processes running on a decentralized agent network, how do you turn that into an intelligent machine by engineering the cooperative interactions of agents? So some of these agents are being predictors, some of these agents are being traders, some might be advisors to the predictors or traders. So it's not just expecting intelligence to randomly crystallize out of that mass of agents. You're creating particular incentive games. You're having particular classes of agents interacting according to these incentive games, and then the intelligence pops out. And he's starting with predicting crypto finance time series because that's the easy way to get started, right? But you can then apply it to predicting the weather. You can apply it to predicting supply chains. You can apply it to predicting supply chains of software and information feeding into other software, and you then have a sort of global brain emerging from that, and predicting and trading architecture. So that's all interesting. I think it's all possible. The approach I think is most promising and is going to get us there first is none of those. So I think all of those can play a role. As I alluded to this morning, I'm betting on, both conceptually, and I'm betting SingularityNET Foundation's resources on, right? Like creating a decentralized AGI architecture with a specific design, and this is OpenCog Hyperon design, which incorporates LLMs and other deep neural nets, but in a subordinate rather than central role. So I'm thinking, make a decentralized Hyperon network, which is an agent pursuing goals in its environment, in a combination of this environment, of many environments. It works toward its goals by a combination of logical reasoning, evolutionary learning, various deep neural nets, a few other algorithms in the mix. It's deployed on a decentralized infrastructure, but then this central AI agent, this sort of decentralized hub of the larger decentralized network, can be augmented and aided and accelerated in its intelligence by a whole bunch of other agents that are sort of forming a periphery around it, and which can then interact with each other in complex ways, right? So I think we can get a rich DApp ecosystem on the SingularityNET and ASI platform, where the dApps are sharing information with each other, and they're crystallizing new collective structures that were not anticipated by any of the authors of the individual dApps. But I think the way we're going to see the formation of this self-organizing DApp ecosystem is by coming out with a sort of singular AGI hub, which is using OpenCog Hyperon augmented by deep neural nets to do smart things that other systems aren't doing now. And wrapped up here is the question of what is the incentive for AI developers to build products on decentralized networks. I mean, right now, the incentives are primarily negative incentives, right? Because blockchain networks are slower, more awkward to use, and more expensive than conventional sort of Web 2 infrastructure, just from an AI developer's point of view. Now, that's becoming less and less so, right? Web 3 is getting more usable, it's getting cheaper, it's getting faster. On the other hand, big tech's Web 2 infrastructure is also getting easier to use, cheaper and faster, and they have so much money behind doing it, right? So it feels like the closest thing to a sure thing we have is launch something smarter and more useful for many applications, happens to be in a decentralized infrastructure. Then, lo and behold, we have this amazing decentralized layer that lets us self-organizing emergent mind crystallize from a DApp ecosystem, right? And the big risk here, of course, is that we don't actually know how to build something that's much smarter than big tech is offering. But I believe that we do. I've laid out the case for that, for the OpenCog Hyperon approach to AGI and a number of other talks before, many of which are available on YouTube. I'm not going to try to do it full justice in the next 5 minutes or so, but I'll highlight a couple aspects. And if you wanted to start from LLMs, which is not at all where I started in my thinking about AGI, nor would I mostly think about when I think about AGI, but just from a rhetorical perspective, start with LLMs. What are they good at? What are they bad at? We can see a couple of things they're bad at are grounding knowledge, grounding their generations in reality. They're also bad at being creative in a fundamental way that's not just very shallowly recombining the surface forms that were fed into them. These are tied in with their lack of a coherent model of the world, because the coherent model of the world, at least self-coherent, even if not agreeing with everyone else, is key to the more purposive creativity that human artists create. And of course, the coherent model of the world is what we use to ground knowledge in observed facts, right? So one thing you can do is try to connect an LLM with another representation that contains a coherent model of the world, right? And The use of that to help LLMs hallucinate less and ground themselves in facts is obvious. The use for computational creativity is also obvious because throw out creative ideas that are all over the place. You need some way to compare them to reality, or else it's just too much, right? I mean, if you have no way to compare your productions to reality, the result is actually you have to constrain in many contexts. So, like if I'm writing music, the fact that I can listen to it and see if it sounds good to me or not is important, right? And that means I can play any random shit, but if I like how it sounds, I won't keep the recording, right? If I couldn't listen to how it sounded, the low risk thing is just to vary on music that I already know because the odds are higher that it sounds okay, right? So by grounding LLMs in a model of reality, embodied, for example, in a knowledge graph, you're both giving their fact groundedness, and which can drive multi-step logical reasoning, and you're getting the groundwork for more radical creativity, right? And so that's a place to start. That part is embodied in the ASI Create product that Nick will talk about a little bit later. But once you're there, then you say, okay, well, what's the best way to leverage these knowledge graphs? Well, you don't just want to suck the information out of them. You want to be able to do reasoning based on them, right? But then hold on, if you want to be able to do reasoning, logical reasoning, deductive, inductive, abductive reasoning based on what's in your knowledge graph, so as to better utilize the knowledge graph within your LLM, right? Then, okay, hold on, how do you control that reasoning, right? Because logical reasoning gives you combinatorial explosions of too many possible reasoning chains to follow. Well, to control that reasoning, maybe you need a way for the system to focus its attention, right? Maybe you need some little cognitive reasoning control procedures. But then how do you learn those procedures? Oh, you need procedural learning, right? So if you start with LLMs and start with the idea of augmenting them with knowledge graphs, which is a very nitty-gritty sort of commercial product thing to do now, step by step, you're led into wanting to build a whole cognitive architecture, which has all the key elements that a human-like mind has, right? And another place to start, on the other hand, which is more the way I tend to think about AGI with my researcher hat on, start with simple systems that are experiencing the world, exploring the world. They're being open-ended intelligences. They're maintaining their individual boundaries in the world. They're surviving. They're also growing and developing and transforming themselves. They're transforming themselves into forms their previous versions wouldn't have even recognized. And this combination of individuation and self-transformation is what Weaver called open-ended intelligence in his PhD thesis and book of that name. An open-ended intelligent agent freely exploring an environment is a different way to start working toward AGI, because LLMs currently are not that, right? Like, they don't know who they are, they don't know what their environment is, they literally don't know what they're doing, right? Now, we're exploring within the SingularityNET ecosystem, we're exploring simple experiential learning agents within video game environments. Alexei Potapov, who will be up here soon, has done some of this within Minecraft. Barrett Cook, Patrick Hammer, and others have done this within other simple 2D game worlds. We're expanding that within the Sophiaverse project to larger, more complex, multi-featured 3D worlds. And within the Mind Children project, as well as in our long-standing partnership with Hanson Robotics, we're exploring that within humanoid robots living here with us in our own world, right? And so taking the relatively simple software we now have for these experiential learning agents and then extending it is another route toward AGI, which doesn't start with LLMs at all, right? And if you look at what, for example, Barrett Cook, who's here in Thailand now, what he's doing, he has a system called Iris, which does one-shot or few-shot learning from experience. So unlike typical neural net reinforcement learning algorithms that need a lot of examples to learn how to do an action, his system needs very few examples to learn how to do an action by combining symbolic pattern learning with neural learning, right? But starting with something like that, if you want to expand it toward an AGI, well, you need to add more long-term memory. You need to add more episodic memory. Then you need to add more reasoning so it can extrapolate better from the patterns I've learned before to new patterns. Then you need a reasoning engine. And if your AI system is carrying out complex procedures that span a long period of time, right, then you want some procedure learning method that can balance together goals over periods of time. So in the end, the cognitive architecture we developed in OpenCog Hyperon, it appears as the natural end game from starting with LLMs plus knowledge graphs as a commercial product. It appears as the natural end game if you start with experiential learning systems trying to sort of demonstrate open-ended intelligence as they make their way through simple game world robotic environments. And in either case, what we're working toward is a system which is, it's got a large body of knowledge. It's got multiple kinds of knowledge represented in an interlinked way. And you could do that in many ways. We are representing this in a sort of distributed, decentralized knowledge metagraph now. But the main point of this knowledge metagraph is you're representing declarative knowledge, procedural knowledge, sensory knowledge, attentional knowledge, knowledge about goals. You're representing all these kinds of knowledge in the same meta-representational fabric so that they can all connect to each other and that patterns can be recognized across them, right? That's the really important thing. The fact that it's a metagraph is convenient given the way computers and programming languages work now. So we have this sort of cross-modal, cross-knowledge type knowledge store, which in our case is a knowledge metagraph, right? And then we're representing not only what's learned about the world in there, we're representing the processes and procedures of thinking in the same knowledge metagraph, right? So our logic engine is in there, not just the logic rules. Our procedure learning engine is in there, not just the procedures that are learned. Visual patterns are in there, but also our visual pattern recognition network can be in there, right? These are all in this big knowledge metagraph. And then the AGI program, which does the thinking, is just cognitive content inside this knowledge metagraph, right? And I mean, we put decades of work into how to do all this, scale it up to the level that we needed to really see what we can do, right? And one of the lessons from the recent successes of transformer neural nets is taking modest variations on already existing AI algorithms and scaling them up massively, and more data and compute can lead to tremendously superior results, right? So the hypothesis underlying our work on OpenCog Hyperon is by taking this sort of hybrid, cross-paradigm, cross-modal knowledge metagraph-based AGI architecture and scaling it up massively, then we can get massively more exciting results. And we've been working on the infrastructure for this for the last couple years. It now takes the form of a structure called the Hyperon atom space, which is a knowledge metagraph, distributed atom space, which lets you store bits of this across many different machines and coordinate them together, and which is connected to the decentralized infrastructure of SingularityNET and ASI. And then a programming language called Meta, which is represented as a certain subset of nodes and links within this atom space. This is now a usable thing. So we have a bunch of developers within SingularityNET and some just interested people within the community who are coding with the open source alpha version of Meta. It works. It's not as scalable as we need. We have several different overlapping efforts to make it 1 million times faster than it is now. Several of them seem to be going very well in the sense that they can massively accelerate subsets of the meta languages, significant subsets right now. It appears that by sometime early next year, we will have a much, much faster meta interpreter. we'll have it connected to the distributed atom space, and we will then be able to start doing real experiments in scalable proto-AGI using Hyperon architecture, both within the context of the ASI Create product, serving the needs of practical AI developers who want to improve what their LLMs are doing in their commercial applications, and from the standpoint of beefing up these simple experiential learning agents that we're doing in game worlds and with robots in limited environments. So this is quite a fun time to be doing these things. I want to add just one more comment on the blockchain underpinnings of it. So we already have the infrastructure to run all this on a decentralized network. Like, we can roll this out on a bunch of nodes running on a bunch of different people's computers, and we can do that on a network with no central owner or controller, and it works. Like, SingularityNET platform has worked for a long time, right? So on the other hand, we can make this decentralized underpinning better and better, right? And one thing that would be interesting will be to scale down our use of the blockchain. The way it works now would be a fairly big, chunky OpenCog system, or a big neural net would run on a SingularityNet node and then talk to others. That's fine. Would also be interesting if you could have an AI microservice, like have a little bitty piece of AI code be its own node running on the blockchain. So then, for example, if you're using a genetic algorithm, instead of having the whole evolving population of entities trying to optimize a certain objective function running within one container, which is a node on SingularityNet, you could have each element of the evolving population be its own node living on the blockchain, so that the operation of the genetic itself consists of a set of operations, right? And that would simply be too expensive to do with Singularity Fetch or any existing AI agent infrastructure. I believe we can do that, though, by leveraging the Toda ledgerless blockchain invented by Tufi Saliba and Dan Tolliver. And all this is already enough, but what we have that's even better, and we discussed at the Singularity Community Day yesterday, is a whole bunch of vertical market-specific applications being pursued by SingularityNet spin-offs, joint ventures, partners, and other ecosystem companies, which are building software that's ideally geared up to leverage all this, to do, say, longevity biology in Rejuve, and perform various AI music operations in Gem Galaxy and Deep Noise Labs, and provide AI to generate and filter and sort between media in Mindplex, and create digital twins of people as in Twin Protocol, and on and on. There's a longer list than I even have time to give now. So we could build this, and I can't leave out Singularity Finance and DeFi, I guess, but since I see Nate back there, we could simply build Hyperon, build the decentralized infrastructure, and say, okay, come build some dApps doing amazing things, and that will be fine. On the other hand, what we have is even better. We have a bunch of projects we specifically incubated that already have thought through how to leverage all this infrastructure to deliver amazing functionality. So it's a lot of pieces coming together, and while it's a lot, actually, it's still not enough, right? I mean, I think it's enough ideas, it's enough software architectures, but if you compare our community, even after the merger into ASI Alliance, if you compare our community to a single big tech company, obviously we're still very, very small, not in terms of ideas and inventiveness and creativity and goodwill, but in terms of amount of money and amount of human beings, right? So in order to overcome that deficit, now, you can overcome that a lot just with better ideas, right? But on the other hand, the other ingredient to overcoming that is community, right? And that's one of the good things about the blockchain and token world, really. I mean, there's a lot of really annoying and time-wasting things about the crypto world, which I'm not going to waste your time to tell you about because most of you have figured them out already. But one of the things that is, you do have active communities integrating people from multiple countries and walks of life, aggregating them together to talk about the same things and work on the same things. So leveraging the community that we built around SingularityNET and ASI Alliance, growing that community is also quite important for following the path that I've outlined toward general intelligence. And it's also important for working toward a future where that general intelligence is beneficial and working toward the broader human good. Because to make AGI is one thing, and I've outlined the approach I think we can take there. To make AGI beneficial to humans and other sentient beings is a different thing. It needs a number of things to be done right. It needs the architecture for the AI mind of having a deep I-thou bonding relationship with another mind and empathizing and feeling compassion. I mean, LLMs don't do that. Like ChatGPT doesn't know who you are. It doesn't know who it is. It is purely transactional. It objectifies you. You objectify it. If you're not an idiot, anyway. I mean, you want an AI that doesn't objectify you and doesn't drive you to objectify it, but has a profound sort of I-thou sharing relationship with you, right? And so you need that architecture, but you then also need to be applying that architecture to beneficial things, like not only, say, selling, killing, spying, gambling, and plagiarizing, and the other primary focuses of the commercial AI industry. It can do those things. People will do it, but you need the AGI to be dealing with education, with healthcare, with mental health issues. You need it to be helping people in a positive way. And to get there, you want to bring in a large community of developers who understand each of these beneficial applications and have been working on these things for their lives. You also need the ownership and control not to be centralized in entities with their own very special goals and obsessions, which is, of course, what the decentralized underpinning is about. So I think we have a community which is decent sized and enthusiastic, and there's a couple initiatives to further grow and leverage that community that I'll very briefly mention, and then we'll move on to the next panel. So the Deep Funding program, led by Jan Horlings, who's in the audience, is a program for offering tokens to incentivize people to build stuff on SingularityNET platform, and we can leverage that in a variety of ways. There's a call for proposals out there right now, which is for developers to propose to implement a bunch of particular kinds of AI within the Hyperon architecture running on SingularityNET. We're also talking about a future call for proposals just for social benefit stuff built on top of SingularityNET. And so this is offering people real money, or as real as crypto gets anyway. I mean, it's offering people tokens that they can use in exchange for doing stuff for the broader benefit of SingularityNET and the world, right? And then another initiative, which is newer, but I think can become equally important, we'll hear about, I think, in the final panel today, which is the BGI Nexus, Beneficial General Intelligence Nexus, which is trying to pull together a broad scope of people who aren't necessarily software developers, AI developers, but want to give and participate in some other way toward these goals. And this is very important also. So, yeah, there we go. That's best I could do today in 30 minutes to summarize how we're aiming to build a decentralized, beneficial AGI. There's a lot of moving parts. On the other hand, these things get miraculously easier and easier to build and pull together as we get closer to the singularity. And I think it's entirely possible in this way to pull together a decentralized AGI within the next, let us say, 2 to 5 years. I mean, there's no guarantee. You could always hit hidden rocks, but I don't think it's implausible at this point, which is quite remarkable. And I would say we have in the ASI Alliance and SingularityNET community, We have both the most credible and mature decentralized platform for AI, and we have the most credible non-big tech AGI project, and the most credible non-deep neural net approach to AGI. So we've got a lot of potential here coming together in a nicely integrated way, and at least as importantly, we have an amazing group of people cooperating together to make this happen. We will shortly hear from a number of those people.